Hey everyone, Nick Apicella here, owner of ResoNix Sound Solutions and co-owner of Vanguard Automotive Design. Before we start this video, I just wanted to fill you all in on something new and exciting for ResoNix and Vanguard customers. We have a new private support group on Facebook that is dedicated to helping our customers with anything they may need regarding the installation or tuning of the products they purchase through us. This means anytime you may have a question, you can post right in the group and you will get personalized help directly from me regarding the products that you have purchased from us. We are also doing videos and write-ups of various aspects of sound treatment, Helix DSPs, and other installation tips and tricks that anyone in the group can request. This is one of 2 videos that will be available outside of the private Facebook group. This is also the only place where you may find discount codes for future orders, as ResoNix products will never go on sale officially. How to get into the group is simple. Just go to the description of the video below and you will see a link to the Facebook group. There is one requirement. This group is limited to ResoNix and Vanguard customers only who have spent $250 or more with us in the past. When you join the group, you must have your order number or invoice number and type that into the appropriate group membership question. If you request to join the group and you do not enter in an order number, the request will be denied and filtered automatically by Facebook. If you do not have your previous order confirmation emails to obtain your order number, feel free to reach out to me via email or on Facebook directly, and we can get that right over to you. Thanks again for everything. I really cannot wait to continue to grow this community together with you. Now, onto our regularly scheduled programming. What's going on, everybody? Nick from ResoNix Sound Solutions here with our first tech tip video. This one was going to be quick. I figured I'd just do it in between a few things I have to do today. This is going to be a video to show you how to use Winisd to model drivers and, figure out which one's going to be best for your application or, other people's applications, or even use it for those industry professionals out there, figure out which is going to be best for your clients' vehicles. So I'm going to show you how to, input drivers and how to manipulate their settings and how to actually fully model a speaker to predict how it is going to behave in given situations. We're going to do a few different versions of this. I'm going to show you a subwoofer, I'm going to show you a mid-bass, and I'm going to show you a mid-range. Yes, you can use this for any speaker. You don't need to use this just for subwoofers. Now, this does not tell you what speaker is going to sound better, but it will tell you, how your driver is going to perform in a given enclosure with given amounts of power applied with given crossover settings and EQ settings. And we can see, which one's going to have the most output, the most low frequency extension, what can get away with what size enclosure, and so on and so forth. So to get this started, I'm going to teach you how to input settings on a few of these drivers. And I specifically selected certain ones that I've modeled in the past because they bring up certain what would be questions that I can just go over in this video. So we're going to start by clicking New Project and New, and I'm going to do the Illusion Audio C12 Shallow Subwoofer. And I have already done this before, this exact speaker, so I'm just going to put just for the video. Now, manufacturer, brand, model, and then once you're done filling this out, you come to parameters. Now, these are all of your TS parameters that you can put in. You don't need all of these. Ideally, you would have as many as possible, but to actually model a driver, all you need are these top sections in theory, but it won't give you the full set of information. I'm going to show you how Winisd recommends you input parameters. The first thing they suggest you to do is start with MMS and CMS, MMS being the moving mass, CMS being the compliance of the suspension. And these two, as you can see right down here, we have auto calculate unknowns. When you put in these two, it will calculate resonant frequency. So yeah, let's hop into this. You know, we have, you know what, let me just do this right here. Give me 1 second. All right. Whoops. All right. So, MMS, we got 251.66 grams. CMS, we have 128 micronewtons, 128. All right, see, now that is going to generate resonant frequency, which is 28.04. I like to always double check the ones that auto calculate. So it was very close. So that means one of the ones that we put in, or one of the ones that was generated, is rounded up to a degree. So yeah, now we do resistance, which in this case it's a single 4 ohm driver, but in the case of dual coil drivers, they're almost always measured in series. So, you know, if it doesn't show the series resistance, if it just shows, like, let's say it's a dual 1 ohm subwoofer, it says 1 + 1, you're probably just going to want to put 2 here to equal, you know, the 2 ohms it would be in series, because almost every time that a manufacturer grabs TS parameters, it's going to be with coils in series. But yeah, like I said, this is a single coil sub, so we are going to stick with, you know, it's simple. So 3.67. Then we're going to go down to SD, which in this case is 464. LE. This is one that a lot of manufacturers like to leave out because it kind of can mask some performance discrepancies. But if it is available, you know, I suggest putting it in because it could show you the top end roll off. A lot of these beefy, you know, subwoofers that you see being used these days, a lot of those manufacturers won't include this spec because when you actually model it, it looks pretty ugly. Yeah, so we're putting in the LE, which is microhenries. BL, now we have to figure out, so 17.59 Tesla meters, which, by the way, if you see all of these little, you know, things right next to the where you enter, you can change, you know, what their unit of measurement is. You want to take note of that when entering these. So in this case on BL, it is, where is it? 17.59. That is going to generate QES. From here, we're going to put in QMS, which is 2.94. And then from here, it's going to generate QTS, RMS, and a few other ones. So we just want to make sure QTS matches the target. So yeah, 0.446, 0.45, that is very close. From here, we only really have to put in Xmax, which in this case is 12 millimeters. So from here, we can save. If you get an error when you click save here, that means something is wrong, whether it's an auto calculation that was changed or modified. Winisd doesn't like when you change its auto calculations or mess with it. So if you get an error, your best, you know, the only way you're going to really get it is to just close it out and start fresh on a new driver. We're going to click save, and then we can pull it in here. So we click new driver, Illusion C12 for the ResoNix video. Next, actually, let me go back. So yeah, driver name. Next, how many drivers you want to use? We're just going to do one. Next, what type of box? Sealed, vented, 4th order, 6th order, yada yada yada. We're going to stick with closed for now. Next, and then you can start with what box size is going to give you a certain QTC. In most situations, people go with 0.707, and we'll stick there. That's the default, and we'll click finish. And it's going to give us, you know, a little measurement here. Now, what I see a lot of people doing wrong is they click that button and it generates this graph, and then they, you know, let's just say pick another subwoofer, and, you know, they look at these two and they're like, oh, this one plays lower, this one is louder in these areas. But the thing is, this is only measuring transfer function magnitude. This is only showing you an arbitrary frequency response that has no correlation to actual SPL. It doesn't show you Xmax. It doesn't show you really anything other than the shape of the response and what it will be. So I'm going to show you how to actually figure all of that out. So from here, we're going to start with the box. Are you planning on building the box around the sub? If that's the case, you can just go with what Winisd recommends depending on the QTC you want. So let's say you're going for the 0.707 QTC. You'll just stick with the recommended. If you want to try to go for something lower, like a critically damped at 0.5 QTC, you can start manipulating the box size to try to get the QTC that you want. So yeah, I'm just going to stick with 1 cubic foot. But yeah, you can play around with that. Or, if you're using this subwoofer in an enclosure that's already predetermined because, your car or your install is limited and you can't build a box over a certain size, you can just put in that limited box and just let it see what it gives you. This isn't terrible. We're not going to really go over that now. But moving on from here, we can input signal. So let's say, I'm using this is a 4 ohm driver. Let's say I use an amplifier that does 500 watts at 4 ohms. I could put in 500 watts here under signal. And as you can see, just from 1 watt to, 500 watts, none of this changes because again, it is just transfer function magnitude. This doesn't really serve you any real purpose. I'm going to go back to 1 here real quick just to show you. But from here, we actually want to click this down and select SPL. Now you see where this is going. We input, we're at 1 watt right now. If we put this in at 500, now you see, okay, that's where we get an actual idea of where output's going to be. But the next question I already know is, well, why is there so much roll off on the low end? This is a theoretical anechoic generated response. So this is purely based off of the TS parameters with no room involved. This is 0 room involvement. This is as if you measured this speaker in the middle of the sky, or if you're in an anechoic chamber where there is no room gain. There are ways to simulate room gain, but we're not going to get into that right now. So yeah, let's say, from here, you're like, oh, I'm going to use, an 80 hertz low pass filter. You can go over here to EQ and filter, hit add, do low pass, select your filter type. Linkwitz-Riley 4th orders are popular. And we're going to just type in, since it's 4th order only, you actually don't need to change this. If you do, it's, whatever, but even if there's 2 or whatever numbers in here, it's not going to matter if you have Linkwitz-Riley 4th order only, it's going to automatically do it. But we could put in, 80. And this is our theoretical response in no room. So if we want to simulate a room, there are videos that can show you how to do that. I am not going to get into it. What I will do is include a link to show you how to do it. Aaron Hardison has made a video on that, so I'll just, link his right here in the video so I can, make this a little shorter and easier. So yeah, this is where we're ending up. But now, we should check excursion because, that's one of the factors of, figuring out what speaker we need to use. So we can click this down again and come down to the driver's cone excursion. And we can see the 12 millimeters of excursion. We are actually not surpassing that. But again, let's just say now you're like, oh, I want to get a critically damped enclosure, of a 0.5 QTC. You can now see that excursion goes way outside of Xmax. And this is how you can determine what size enclosure you could get away with and how much power you can get away with, while also showing how much SPL you can really expect, especially versus another driver. So let's take, another speaker. Let's just say, JBL 10 GTI. Let me just look at the parameters here to see if this is even comparable. It is. All right. So this is, the JBL GTI. Everyone knows what that is. It's a pretty deep subwoofer. So we'll be comparing that to a shallow subwoofer. This JBL is probably going to have much more power handling, much more output. But, let's see what happens here. So we're going to go with a closed box as well, just to make it, relatively straightforward. Let's change the color here so it's easy to see which one is which. Box size. Let's just put this in, let's say the box is going to be the same for both of them. Let's just put them both in a 2 cubic foot enclosure, okay? This one, let's say the same amplifier is being used. We can put 500 watts on it. And you can see, okay, EQ, and 80 hertz low pass, and they're actually damn near identical. But, what you could do from here is now go back down to excursion, and you can see, oh wow, actually, this is not what I expected from the GTI. It looks like this does not even have as much power handling as this Illusion Audio C12. Oh, that was the exact opposite end result that I expected. So you know what? Let's get rid of this one. Let's do something that I know has a ton of output. JL Audio, let's see if there's a 12W7 in here. 12W7, there we go. So we're gonna do one of these closed enclosure, and let's go back to SPL. Actually, you know what? Let's go to transfer function. It looks like, oh, by the way, this is what happens when you don't put in an inductance spec. It looks like you have a flat response all the way up, which is not true. And you will see maybe later on why that could be a problem when trying to model some of these subwoofers or mid-bass drivers or mid-range drivers. But anyways, let's stick to what we're doing right now. Let's, again, stick this in a perfectly 2 cubic foot enclosure so it's exactly the same. Put on 500 watts of power applied to it. And let's add this 80 hertz low pass filter. Okay? And you see, they're actually pretty similar too in transfer function magnitude. But when we get to SPL, you'll see that the W7 has a little bit more output across the board. In the middle of the bandwidth, we're at about, we're going from 110 and a quarter to, 107 and a half. So we're at about almost 3 dB difference. But here is where things get interesting. We can go into the excursion and we can see, we know that the C12 has 12 millimeters of excursion. So that is actually technically maxing out with more than 500 watts, with 500 watts of power in a 2 cubic foot enclosure. So we either have to lower the amount of power applied or lower the enclosure size. I'm going to say, just to keep it simple, let's just, go with, let's just go with power applied. So at 20 hertz, let's just ignore below 20 hertz, there we go. 250 watts, we're at the 12 millimeters of excursion, or very close to it. But as you can see, the JL Audio W7 has 29.2 millimeters of one-way excursion. And with the 500 watts applied, we are nowhere near that amount of excursion. So let's just see, let's see what we can do to get up there. Yeah, let's say, 1,300 watts of power, and we end up reaching the excursion for the W7 in a 2 cubic foot enclosure. By the way, just really quick, let me show you what happens to excursion when you lower or raise the box size. If I lower the box size, excursion is limited drastically. A sealed enclosure can just be looked at as a high pass filter, to be honest. Let's go back to 2 cubic feet here. But now let's look at SPL. You will see now that the W7 is at 114.5 versus the Illusion's 104.5. So we're at 10 dB higher with the W7 around 50 hertz, and down low, let's say at 20 hertz, we are at 95.5 versus 104 area. So almost another 10 dB down at 20 hertz. So this is how you can model one subwoofer against another to see what is going to give you the most output and how one is going to behave differently than another in given enclosures and power applications. Now let's do a mid-bass driver. This is where I want to show you some of the problems that you might run into when inputting parameters. I'm going to put in one in specific, or one from a company in specific that I know uses some funky units of measurement. It's not that the measurements are wrong, it's just the units they use are very strange compared to what is usually done. So we're going to do the Blam Multix WS8, the new 8-inch mid-bass driver. And we can see that right here. And the spec I'm talking about in particular is their CMS. This isn't one that I really see used much, in meters per Newton, but mostly the inductance, ultra Henry instead of micro Henry. So these are little things that you need to watch out for and, keep in mind. So yeah, that being said, let's get into it. All right, parameters. You know what? All right, so MMS is 25.05 grams. Now, let's say for the sake of the argument, the CMS spec, let's say they didn't include this meters per Newton. Like, let's just say they just throw out a number with no clarification on what the unit was measured in. What we could do is just take the resonant frequency, 45.6, and now that will generate our CMS. Now, if we click, meters per Newton, this actually doesn't really, I can't even see if that's meters per Newton. Oh, looks like they have a typo. This should be millimeters per Newton. This is exactly what I'm talking about, where you get some really funky readings. So yeah, so moving on from here, let's do resistance, 2 ohms. SD is, where is SD? 213.82, and that is in centimeters squared, so that doesn't need to change. So see, you can see with inductance, we only have millihenry or Henry, and in this case, we have 142.74 ultra Henrys. So what I like to do is, since I am really bad at math, I'm just going to do this. 142.74, convert it, boom, copy it, paste it, let it rip. And then with BL, we have 5.34 Tesla meters. Yeah, 5.34. That's going to generate QES again. QMS is going to be 7.34. And that's going to generate QTS, RMS, and a few others. Now we got, well, let's see if QTS matches up. 0.55, this comes out at 0.47. So it's close, but it's not exact. Let's see where things went wrong. My guess is, I don't know where it went wrong, but wait, did I 5.34, and QES is, yeah, so QES looks like it was just rounded up here instead of just put in, which again, it's common. It's like nothing against them. It's common for loudspeaker manufacturers to do that instead of having a whole bunch of crazy numbers here. It makes a spec sheet easier to read and understand versus much more congested one. But it's all right anyways, because we can just calculate what these really should be when something doesn't make sense. Now again, inputting Xmax, which is 6 millimeters one way. By the way, Xmax in Winisd is one-way linear Xmax. So if the manufacturer specifies like let's say this was 6 millimeter and specified two-way or like peak to peak or P-P linear excursion, you would actually divide that by 2 and put 3. But in this case, Blam does one-way linear excursion, so we're leaving it at 6. So let's save this. There we go. And let's see what we can do with it. Let's just see how it how the Multics WS8 wants to be used. So we can, it has a high EBP, which is going to want to recommend a sealed enclosure. This is probably because they want to be able to allow users to use this in a small sealed enclosure or infinite baffle. Usually when you have drivers like that, you will end up with a high EBP when you have a loudspeaker that is not sensitive to enclosure size. So this is common in mid-ranges or in some mid-basses. So we're going to go to, sealed because we don't want to mess with a ported mid-bass driver right now. So yeah, we are in SPL again. Usually it's going to start in transfer function. And the box size it gives us, it wants to use a 1 cubic foot enclosure for a 0.707 QTC. But most doors, are going to be about 3 cubic feet, give or take, depending on the car, depending how well sealed it is. So let's just say 3. And it still gives us, an acceptable QTC. It's actually more ideal. Critically damped is technically better. But yeah, let's just see if we bring it down to half a cubic foot. So yeah, it's still below, a QTC of 1, which I consider at least usable. I've gotten away with QTCs as high as, 1.3 or 1.4 in certain cars due to cabin gain helping us out, or, it not being used at a, frequency that's close to the resonant frequency. So, QTC is, only really 100% important if you are playing the speaker at or near the resonant frequency of the driver. But in a subwoofer, you're always going to do that. With mid-bass drivers, you're always going to get close to it, usually. Mid-range drivers, not so much. They're a little bit more forgiving because we're high-passing, mid-range drivers much higher than what the resonant frequency usually is. We'll get into that in a little bit. So yeah, let's just go back. Let's say we're using this in a door, 3 cubic feet. Signal, let's say our amp puts out 150 watts. And, let's not do any crossover or anything yet. Let's see, SPL. Actually, we don't really need to look at SPL, but let's look at the excursion. So as you can see, with no crossover, we are well above the 6 millimeters excursion. But this is a mid-bass driver. This is intended to be used, with a high-pass filter. But, let's just say this is going into a vehicle where, there's no subwoofer, and you can, you really want to get as much low end out of it as possible. What you can do is look for the XMEC spec, which, let's see, is actually not here. It gives us the height of the coil, but it doesn't give us the height of the gap, unless I'm not seeing it. It doesn't give us an XMEC spec, unfortunately. So let's just ignore that for now. So yeah, we can see, let's just say we want to see how low we can really use this with our 150 watts and keep it relatively safe. So we can add, our high pass. Linkowitz Riley 4th order is what I usually stick to. Let's just say, 60 hertz. And perfectly enough, this stays just at Xmax with a 60 hertz 4th order Linkowitz Riley crossover with 150 watts applied in a 3 cubic foot enclosure. So this is realistically, what the SPL of this mid-bass is going to look like without cabin gain applied. So let's say you wanted to use more power. Okay, you wanted to you wanted to have a system where you have much higher volume. Let's say you're throwing 300 watts at them, but you already know that is going to throw excursion well above. So we can manipulate this and see where we really need to cross it in order to get it to not go above excursion. 70 hertz is still a little too low. 80 hertz is, almost perfect. We can get away with probably 75 hertz. And, X max is just when the coil leaves the gap and where distortion, much more distortion starts to become audible or be generated since the coil's leaving the gap. But you can still play a driver outside of excursion and it can survive. X mech, the mechanical limits of the suspension and the top plate and bottom plate is where real damage happens to your coil. But we don't know that spec for this speaker. For a mid-bass driver, usually not concerned. But yeah, this is how you can use Winisd to see what you can really get away with in these applications. Now there is one more thing I want to show you with, let's just say, a mid-range driver. Let me pull up another Blam speaker and we'll model a mid-range and I'll show you what I'm really talking about. Let's do the WS3 or the MS3. I actually think I already have this in here. I don't. All right. So let's say Blam, MS, Multics, MS3. All right, I'm gonna go through this one a little bit quicker. All right. So we got 16. And again, I'm putting in FS instead of CMS because I know their CMS is a little bit wonky, a little difficult to understand. Let's see. See that? This one is correct. It looks like they had a typo on their WS8 mid-bass. So now let's do resistance. 2.1 SD is 120. Wait. I am on the wrong one. Whoopsies. This is the WS6. I want to do a mid-range. So let's clear all of this. We gotta fill this out again. All right, MMS 2.3. Yeah, that makes a lot more sense. FS also 94.82. This one also doesn't have a typo, so it looks like I said, just the WS8 has a typo there. This has 3.44 SD of 29.22 inductance. So, like I said, 16.11. And by the way, inductance for Winisd is done at 1 kilohertz, so we want the 1 kilohertz spec if possible. So let's see, 16.11. This has a very low inductance. All right. BL is going to be 2.52. QES, let's see if that matches. Yeah, 0.74. All right, QTS 0. Oh no, QMS is 5.44. And QTS ends up as 0.653. 0.65, yeah, so this is right on the money. Xmax is 1 millimeter on this mid-range. As this is a wideband, they tend to have lower excursion than their mid-range counterparts. So you know what we'll do is we'll also compare this to the mid-range specific Blam signature speaker. But so let's close that. Let's do another new one. And I actually forget the actual model number of this one. It's gonna be this one right here. MS 3.55. All right. All right, so MMS 2.24. FS is 129.93. RE is going to be 3 ohms. Surface area 29.22. Inductance is going to be 58.18 ultra henries. So I'm converting that to millihenries, which is what Winisd is going to be using. BL we have as, which one am I on? Wrong one. BL is 2.4 Tesla meters. Okay. QES generated into 0.95, which is very close. It's not exact, but it's very close. Okay. QMS is going to be 6.41. Oops. All right, QTS 0.83, 0.89, very close. Yeah, that's definitely acceptable to be that close. An excursion is going to be also 1 millimeter. All right, let's see. All right, so that is good. Save that, and let's do what we got to do. All right, oops. MS3. All right. See, like I said, very common with mid-ranges. As you start getting into drivers that want small sealed enclosures, the EBP will be so high, the effective bandwidth product is going to be so high that the software is going to recommend a vented enclosure. In a lot of these cases, ignore it, or you could use it to see what it's really better suited for. But a lot of these times, you already know what you're going to use and why. So yeah. All right, so let's just go to transfer function. Now we're going to do the signature MS 3.55. All right. Right out of the gate, they have very different transfer functions. Let's put them in, let's put them in a similar enclosure. Let's say they're getting installed. Both of them are getting installed in a dashboard with no enclosure. So let's put a relatively large enclosure here. Let's just say, 1.5 cubic feet we'll put, okay? So we'll see right out of the gate, the MS3 the Multics has a transfer function that plays lower. But let's see what happens. Another thing too is we can right click here, see our options, and we can actually raise the frequency range. And let's go to 20,000 because, that Multics is a wideband. As you can see, the inductance is so low that this does have 0 problems playing up to 20K. It only has a dB.5 of drop, at 20K from its normal bandwidth range, the middle of the bandwidth. So yeah, let's see, we're going to apply, we're going to power them, let's say with a, 75 watt at, whatever their rating. Let's just say they're both getting 75 watts. Actually, what you really could do, if you really want to get, more exact with it, is look exactly at the RE. The MS3 has an RE of 3.44. This has an RE of 3. So, RE meaning resistance at, DC. So we can actually give a little bit more power to the MS3 to simulate an amplifier with an unregulated power supply. So let's say like this one was getting 75 watts. Like let's take a Helix V8, for example. At 4 ohms, it's going to do 75 watts, but at 2 ohms, it does 125. So, somewhere in between here, we could probably go up to like 80 on this, since this is 3.4, and at 3 ohms, we can probably go up to like, we could actually probably go up to 85 here, and let's say this one is going to be, 100, just because it has a lower resistance. Now, let's see where we are with SPL. So as you can see, we actually do have more output in a given passband, which is the mid-range for the mid-range specific driver. Would you look at that? It's almost as if they were designing these speakers for their intended use for a reason. Look at that. But, you know, the Multics being a wideband does have a much wider bandwidth. Let's look at the excursion. This is going to be way up since we do not have crossovers applied. Let's also get a higher resolution on the excursion. Let's go up to, you know, 5 millimeters just so we can really see better. So let's apply, you know, let's say this is what our end result is going to be. Let's say, all right, let's see how low these can play. So high pass, link widths, you know, let's say 200 hertz. And this is still, you know, that's too high of a crossover here. So we got to get this, you know, for the power applied, that said, you know, so we got to get this maybe to 350. That's, you know, little too high. It's definitely safer, but we can definitely go lower with it. You know, about 300 hertz is perfect. Let's see what we can do with the mid-range, the signature MS 3.55. Let's say 250, a little too high. Let's say 300. It's actually, this one needs to be crossed over a little higher, it seems like. But it is getting more power applied, so it is getting a little bit more output. So let's say, yeah, that's where they match. You know, they're just creeping right above their, you know, excursion limits. But now let's look at, you know, the SPL across the board. Again, the MS3, the Multics, the one that's designed to be a wideband, is definitely dominating as a wideband. But if we look in the SPL area, we're actually getting, you know, about maybe a dB or so. Yeah, about a dB or so extra volume from the MS3 in its given target range. So yeah, this is, you know, it's a very simple tool. You know, I know there's a lot of different options in here, but it is a very simple tool that you can use to figure out what is going to be best in your situation or what your limits are in your situation. If you think there's anything I didn't cover, you know, feel free to comment below and maybe I'll make a separate video and, you know, cover what you're looking for. So yeah, thanks, stay tuned, and I'll see you guys later.